Welcome to Watch This Space. I'm NASA Administrator Jim Bridenstine, and NASA is going forward to the moon. This time, we're doing it differently than we've ever done it before. Recently, NASA announced 9 commercial partners that will take NASA payloads to the surface of the moon. These are highlights from that recent announcement. Not only are we announcing today a number of very innovative companies that are going to go to the moon for the first time commercially. In other words, we're going to buy the service. We're not going to purchase, own, and operate the hardware. We're going to buy the service. But we're also announcing a change that I think is important for NASA. And that is, this is a response to the science community, who has for a long time decided that we needed to do science on the surface of the moon, and yet NASA for a long time has focused the moon within the Human Exploration and Operations Mission Directorate and not the Science Mission Directorate. But now we're changing that. We believe there is a lot of amazing science that we can do on the surface of the moon. In fact, science that we can't do anywhere other than the surface of the moon. We want multiple providers that are competing on cost and innovation so that we as NASA can do more than we've ever been able to do before and advance the human spirit.
Science and human exploration go together. And we should not be surprised that I'm standing here as a scientist really excited about exploring this celestial body right next door to us. The moon, like any other body in the solar system. The moon is full of secrets that we don't know yet. For example, if you really want to decide what the age is of the solar system, just like you look at the rings of a tree when you cut it, if you want to learn that, you go to the moon and you analyze the samples that are there.
Today we are at the Jet Propulsion Laboratory, the Charles Elachi Mission Control Center, where we had the opportunity to participate in the Mars InSight lander. I am here with Emily Manor Chapman, who is an instrument engineer on the Mars InSight lander. And of course, today we've had a very exciting day and, in fact, a very successful day. Her part in this was the development of instruments that have been, not just engineered, but built and now delivered to the surface of Mars. So congratulations on a wonderful day.
Thank you so much. Definitely so exciting today.
That's so great. Tell me, what is the instrument package that you worked on?
I work with what we call the Auxiliary Payload Sensor Suite, which is a collection of environmental or weather sensors.
Oh.
So we have a sensor that can measure air temperature and wind speed, atmospheric pressure, and also a magnetometer that can measure the magnetic field at Mars.
So tell us, are we going to get like continuous updates on the weather, on Mars?
We will. Starting this week, we'll do a short checkout with the instrument just to make sure everything is working correctly after landing. If that's successful, then we'll turn on the instrument and it basically stays on almost continuously at that point. So we will get a full sol's worth of weather data every sol.
How long is it going to take before, there's a number of instruments here, and of course your package is one of many instruments.
That's right.
There's a seismometer on the Mars InSight lander, and there's something called the mole. Let's talk about the seismometer first. What is that going to help us understand?
So the seismometer will measure quakes on Mars, or Mars quakes as we call them.
Okay.
And by looking at the type of seismic activity on Mars will tell us something about how Mars formed and what it's made of. So scientists can look at the waves and data picked up by that instrument and tell us about how do seismic waves move through the material on Mars, and looking at how they move, what's Mars made of.
And I've been told that it can even pick up like maybe even meteorites that actually hit the surface of Mars, even on the other side of the planet.
Yeah, that's correct. We think we'll be able to detect those as well.
Wow, that's fantastic. So, okay, the mole. Tell me about the mole.
So the purpose of the mole is to measure how heat changes and moves around inside of Mars. So the mole is kind of a big nail about the size of my forearm, and it can actually hammer itself underneath the surface of Mars. And so with the mole, we're going to go deeper underneath the surface of Mars than any other mission has before. We'll go down to up to about 15 feet. And trailing behind that mole will be a series of temperature sensors. And so it will be able to take temperature over time and again see how the heat is moving around, how is it changing inside Mars. And again, that tells us something about how Mars formed and what it's made of.
Amazing. tell me, what do you know about the core of Mars?
Well, first, if you look at our core here on Earth, we know that we have a kind of molten metallic core, and that core is what drives the magnetic field that we have here at Earth. And so, as you said, we don't see that global magnetic field anymore at Mars. So we want to find out, is the core liquid or is it solid? And what is it made of? Because if we see something that's like, maybe it's a solid core, so you don't have that dynamo action in the center of the planet like we do here on Earth. So we don't have anything to drive that magnetic field of Earth. And so we're actually going to use radio signals, between the lander on Mars and an antenna here on Earth. Looking at changes in that radio signal will tell us about what the core is made of. Is it solid or is it liquid?
So how long until we start getting some really serious science data from InSight?
It will actually be about 2 to 3 months, because the next thing that we need to do with InSight is, so we're on the surface, but when we landed, all of our science instruments are sitting up on top of the lander. And we really want to get our seismometer onto the ground, because it's going to take much better data if it's actually in contact with the Martian surface.
Okay.
And for our probe, obviously it also needs to be on the ground, because we want it to hammer underneath the surface. So the next 2 to 3 months we're going to spend using the robotic arm. And the robotic arm you can think of like one of those carnival games with the claw, and you go and pick stuff up and put it on the ground. And that's basically what a robotic arm is. It has a little claw. You can go pick up the instruments and set them onto the ground. So in the coming couple weeks, we're going to be looking at where did we land, taking lots of images to see what's in front of the lander, picking where do we want to put the seismometer, where do we want to put the mole, and then actually start that process of using the robotic arm to pick up those instruments and get them onto the surface of Mars.
Amazing. Well, Emily, thank you for your great work. What an amazing accomplishment today. We're all so proud of you and your entire team here at the Jet Propulsion Laboratory, and of course the InSight team. So thank you so much for your great work.
Thank you.
Absolutely. Well, I'm here with Vivian Sun, who is a systems engineer here at the Jet Propulsion Laboratory, and she has been involved in picking the landing site for the Mars 2020 rover, which of course is a mission happening in 2020. And we're all very excited about that. So tell us, what goes into selecting a landing site on Mars for the 2020 rover?
Right, so actually this process began several years ago. So it first started in 2013 when an open call was put out to the Mars community, basically saying that anyone who wishes to propose a landing site for this Mars 2020 mission can do so, and the only requirements are that this landing site had to demonstrate that there used to be liquid water at this site, and that this liquid water had a chemistry that could have supported life had it existed on Mars at that time. And so with those requirements, the first landing site workshop was held in 2013, and there were about 30 or so landing site candidates that were put forth by different members of the community. And so at the workshop, we discussed the pros and cons of each site, what each site had to offer, what kind of samples we might collect at every site. And so in this sort of fashion, we've had several more landing site workshops. We just concluded with the fourth and final one this past fall, just about a month ago. And throughout that process, that initial list of 30 landing site candidates was eventually whittled down to the 3 that we had just a month ago, which is, of course, Jezero Crater, Northeast Syrtis, and Columbia Hills.
Okay.
And so at the conclusion of the fourth and final landing site, we discussed again the pros and cons of every location, what a kind of mission might look like to each of those sites, and then we came out with Jezero Crater.
You mentioned that the water was critically important, and
Yes.
maybe the type of chemicals that would have been in that water that may have been able to help support life, and that's what went into the selection process. So what we're actually going to do is cache samples on the surface of Mars with the Mars 2020 rover. What do we get when we cache samples? Why do we do that?
So the reason why we really want to cache samples with Mars 2020, and the reason why this is such a critical step for Mars sample return and understanding the history of Mars and its potential for ancient life, the reason is because even though our rovers are incredibly sophisticated on the surface of Mars, they're still limited compared to the analyses that we could do here on Earth in our laboratories, where we have access to the state-of-the-art technologies. And so to really look at a sample, to look at a rock and be able to tell whether something is a true biosignature or whether it's something that was truly evidence for past life, you really need to do that kind of analysis here on Earth with our sophisticated labs.
Yeah.
Yeah.
So the idea is Mars 2020 just caches a sample. Then we have to do a Mars sample return mission,
Yep.
which of course we don't have a date for yet, but in my view we need to do it as soon as possible to get those samples back to Earth.
Absolutely.
And at the end of it, the goal is to discover whether or not Mars is habitable, or maybe at one time was habitable, or even today, could it have life? Is that the intent here?
Yeah, so for sure we want to understand whether the environments that we're investigating were habitable or not. And from the satellite data, or the orbital data that we have pretty good hints that they're probably habitable, that they used to have water, and that water had chemistry that could have supported life if it existed there. But what we don't know is if there was life. That's one question. If there was life, do we have evidence that preserves, for example, fossils or other biosignatures? Do we have that evidence that there was past life in any of these samples?
Okay.
And that's something that we can only figure out by returning those samples back.
Okay. Well, Vivian, I want to tell you we're grateful for your work. We're looking forward to coming back 26 months from now when we have a successful Mars 2020 landing on the surface of Mars, and we'll revisit this again and talk more in depth about what the next steps are. So thank you so much, and Mars is a wonderful place. We need to learn more.
Yes, we do.
Appreciate it.
Thank you.
You bet. We now have an opportunity to meet Mimi Ung, who of course has been highly involved in what's called Mars Helicopter. So when we send Mars 2020 to Mars in 2020, of course, it's not only going to have the rover, it's also going to have attached to the rover a helicopter that Mimi has been involved in developing now for many years, as a matter of fact.
Over 4 years?
Over 4
4.5
years.
years. Yeah.
So tell me, how did this come to your mind as an idea? Was it out there before? Was it your brainchild? How did this come into being?
No, feasibility of helicopters flying at Mars have been proven in the in the 90s.
Okay.
In fact, Bob Belleram, who's the chief engineer on our project, he had done research in those days showing that it's feasible, it's possible. There's enough atmosphere to fly a helicopter. The challenge, of course, is it has to be very light.
Yeah.
Similarly, over in Ames, Larry Young has some research that have been proven.
Okay.
But the thing that had not made it possible until recently is the availability of technologies for
Okay.
these lightweight, capable flying vehicles.
Okay.
So around 2012 or so, our previous director, Charles Alachi, was on a lab tour, and he was seeing these drones being used to demonstrate autonomous navigation algorithms. And after the tour, he said, hey, why don't we do this at Mars?
Wow.
And so we connected him back. In fact, I happened to be on the bus in his tour because he was visiting our division, Autonomous Systems Division, and I was the Deputy Division's Manager of Autonomous Systems Division at the time. Anyway, so why don't we do this? So we connected him back to Bob Belleram, who had done research in the 90s,
Yeah.
and then he started from there.
Okay.
So
Mimi, tell me, why is it important to have a helicopter on Mars?
today we explore planets from spacecraft in orbit and rovers on the surface, but we're not using the aerial dimension to explore surfaces. So the helicopter would open doors to exploration through aerial dimension.
Yeah.
And that will help with forward reconnaissance, far ahead of rovers, or in the future, astronauts,
Right.
when astronauts are there to explore. And so forward reconnaissance is very important, and it's a new dimension. Secondly, we'll be able to get to places we simply can't get to today.
Right.
And even in the future, with rovers or even astronauts. For example, sites of these cliffs, right? Recently, there are these exposed ice scarps that have, we would have to fly there to get a sample and analyze them on landed assets, or bottom of crevices and steep volcanoes.
Yeah.
A new dimension, adding.
So when the Mars 2020 rover lands, the helicopter will be underneath it. Is that correct?
That's right.
And then it will be released. It will unfold, and then it will take off. How long will it be able to fly?
We plan to do incremental series of flights. So the first thing we would want to do is repeat the flights that we have demonstrated in Mars-like atmospheric density in our 25-foot chamber here at
Yes.
JPL, right?
Yeah.
So that would be the first flight we'll want to do exactly what we have modeled and demonstrated on Earth.
Yeah.
And so we will go up and hover and come down,
Yeah.
go up to 3 meters or so.
I want to take a moment. When you lift off of Mars and then set down on Mars, what do you think that moment will be like?
I would, if I dare say so, it would be just like a Wright brother moment,
Yeah.
really, because flying in this thin atmosphere is, it just hasn't been done before.
Yeah, so
extraordinary.
Tell me about the atmosphere.
It's-
When you compare it to Earth, how does it compare to Earth?
It's very thin.
Yeah.
So compared to Earth, less than 1% of Earth's atmospheric density.
Okay.
So we have algorithms that show that we can fly, we can control, but to really, and we have done experiments on Earth in our chamber, but to definitively demonstrate doing this on Mars is a huge milestone.
It will be. And okay, so as you mentioned, you have your Wright brothers moment where you actually take off the surface of another world and then land again with a helicopter. Okay, then after that, what's the next test that you want to do?
Then we'll start doing incrementally further lateral flights. So we'll ascend and then go laterally, start with modestly with a few tenths of meters, and then come back and land. And then after that, following incrementally further, up to 150 meters or so out and back.
Okay.
And that would fully confirm all the models, all the assumptions that we've done in, and definitively conclude our analysis.
It's weird to think about because when you're in atmosphere that's that thin, as you mentioned, less than 1% of Earth's atmosphere, it seems like once you start going, it becomes very difficult to stop. So everything has to be so much more precise. The way you start moving requires a certain amount of L over D in order to tilt the helicopter and move it. But then you have to be able to stop it. But the atmosphere is sufficiently thin. Does it scale? Is it comparable to Earth's atmosphere? I mean, it seems like it's far more complicated than
it is
what normal people might think that it is.
Yes, it's very counterintuitive. The thin atmosphere reacts, the blades react differently with a thin atmosphere. For example, there are resonances in all rotorcraft, and on Earth, with very thick atmosphere, a lot of the resonances get dampened out.
Sure.
With thin atmosphere, they continue to ring.
Yeah.
So for example, our development, our test, demonstration, and the design and the selection of frequencies have to be very carefully aligned and be aware of those. Reaction of the vehicle, while it's a thin atmosphere, response is actually slower in some sense and faster in others.
Yeah.
So for example, you turn the blade and here on atmosphere, you're pushing so much air, you suddenly turn.
Right.
There, it takes a little longer. So definitely our team had to model from the very fundamentals of a blade, like taking a blade that's, we're 1.2 meter diameter blades, so a rotor system, so half a 0.6 meter or so per blade. We actually had to cut into 33 virtual pieces and analyze them for the lift and the drag of each of the piece with, with the high fidelity CFD analysis. Take the lift and drag, integrated them, and then model how the dynamics of the vehicle would be in this thin atmosphere. These low Reynolds numbers, and this is low density area.
You're starting from scratch.
Starting from scratch, and it's been a surprise, a nice surprise, and it's made it very fun. But definitely starting from the fundamentals.
Right.
So that's why when you asked just now about how would you feel, what does it mean that very first flight, to unconditionally confirm our models in the real environment, it'll be fantastic.
A first of its kind. It'll be monumental. We're so looking forward to seeing it happen. And of course, it's going to be part of the Mars 2020 rover. So it's really not that far away. We're almost there.
Right.
And we look forward to coming back here in 26 months in order to watch a very safe and effective Mars 2020 lander, and thereafter a Mars helicopter take off and land on the surface of another world for the first time in human history. Thank you, Mimi Ung, for all of your great work.
Thank you.
Can't wait
Thank
to
you for
see
your
all of your
support.
accomplishments in the future.
Thank you.
Thank you.
Well, thank you for watching Watch This Space. I'm NASA Administrator Jim Bridenstine. You can follow me on Twitter @Jim Bridenstine. And of course, if you want to watch this again, you can do so at nasa.gov/watchthisSpace.